Hey, it's Mr. P Helps with Precal, Unit 3, Topic 3, Lesson number 2, and we are doing some more simplifying using Pythagorean identities. We'll start off with a warm-up, which is pretty basic, honestly, most of these questions. Sine squared of x plus cosine squared of x, well, that's this Pythagorean identity right here. The answer is 1. 1 over tangent of x, so 1 over tangent of x right here. So reciprocal identities tells us that's cotangent of x. Secant of x multiplied by cosine of x. So secant of x being multiplied. So secant is 1 over cosine of x, and really cosine of x is cosine of x over 1. And you can reduce diagonally, and that becomes 1. Cosecant of x. Now, cosecant of x is right here, so that's 1 over sine of x. And if you multiply that by sine of x, which is really sine of x over 1, these cancel. So this is a very similar question to number 3, so that answer is also 1. All right, so now this one, so we don't have any trig identities here. This is really just basic complex fractions. So I would multiply this one by x over x. That's going to make the denominators the same, so that you now have x squared minus 1 over x, and then your complex fractions, x squared minus 1 over x being multiplied, so change this to multiplication, change the x on the bottom to 1 over x. All right, so now we've got x squared minus 1, because anything times 1 is itself, over x squared. And x squared is not a factor of the top, so therefore this is as far as you can simplify it. You can't go any further than that. All right, so getting into these identity questions, this is kind of like the last video if you just watched it. These are actually pretty basic questions here, and then we're going to go to like mediocre questions, and then the last slide is going to be very, very more challenging questions, to put it loosely. 1 times 1 is 1, so this is just differences of squares, so this is 1 minus cosine squared of theta. And if you look at the Pythagorean identities, so cosine squared of theta minus 1 is equal to sine squared of theta. So that's your answer. This time we are going to multiply these so that we have secant squared of x minus 1 and secant squared of x minus the 1 over here. If you move this 1 over to the other side, the answer is tangent squared of x. Excuse me. I put theta, but it's actually supposed to be x. Excuse me. Sorry. This one over here, so this is going to be sine squared of theta minus 1. And which Pythagorean identity that is? This one right here. So if you move the 1 to the other side, move the cosine to the other side, then you've got negative cosine squared of theta. That's the answer. And tangent squared of x minus secant squared of x, that's actually a pretty basic one right here. So if you move this one over to this side, it's going to be minus. If you move this over to this side, it's going to be negative 1 is your answer. Okay, and next, here we go. A little bit more challenging here. So 1 over cosine squared of x, 1 over cosine squared of x is right here. So that's really secant squared of x. 1, so secant squared of x, actually, hold on, let me see if that's, yeah, that should get me somewhere. Minus 1 over cotangent. 1 over cotangent would be minus tangent squared of theta. I said x, but it's theta. It really doesn't matter what you use. You just want to stay consistent with whatever the question's using. And then if I look over here, secant minus tangent, secant minus tangent is 1. So the answer is just 1 using our Pythagorean identity. 1 minus sine squared of theta over tangent squared of theta. Okay, so I know I can change tangent to look something like cosine. So maybe that's the way I want to go about doing this. So that would be 1 minus sine squared of theta over 1. I just want to put the top over 1. And then tangent squared is the same thing as sine squared of theta over cosine squared of theta. Okay, now I can leave change. So that's, okay, this might not be the most efficient, but this is the way I'm seeing it. So that becomes 1 sine squared theta over 1 being multiplied by sine squared theta over, no, I'm sorry, cosine squared over sine squared of theta, which these basically cancel out. You're left with 1 cosine squared theta. So this is really 1 minus cosine squared of theta, which then you can 1 minus cosine, which is sine. So that's using this Pythagorean right there, and that's sine squared of theta is your answer. All right, the next one, 1 over sine squared of theta. 1 over sine is cosecant. Minus 1 over tangent squared of theta. All right, I paused just to make sure I was going in the right direction, which I was. 1 over sine squared is, as I just said, that's cosecant of theta, cosecant squared of theta. And minus 1 over tangent would be cotangent, so most cotangent squared of theta. And then if you look at the Pythagorean identities, if you move this to the other side, and you've got 1 as your answer. Okay, so this one is being multiplied by both of these. So maybe if I could simplify this, that would have been a little bit easier, but I don't think I can go that route. Secant and cosine are never in any of these identities together. So cosine of x times secant of x minus cosine of x squared, because this times this is cosine x squared. All right, so what can I do with this now? So secant of x is the same thing as 1 over cosine of x. So cosine of x over 1 multiplied by secant of x, which is really 1 over cosine of x. Okay, well, this is nice because this is going to cancel out, and that's really just 1. So now we have 1 minus cosine squared of x. And that's going to be one of the Pythagorean identities, and that is sine squared of x is your answer. Okay, so fairly basic questions in this case. Well, those are actually a little bit more challenging than the last page, but now we're going to get to some really tough questions. So number 9, first thing I need to do is I need to multiply. So using FOIL, so that's going to be 1 times this and this. So that's going to be cosecant of b. 1 times this is plus cotangent of b minus, let's see, so this will be cosine of b times cosecant of b. And then this times this will be minus cosine of b times cotangent of b. Okay, so let's focus on the 2 on the inside first. So cotangent of b is really 1 over, here we go. Cotangent of b is really cosine over sine. So this is really cosine of b over sine of b, and minus, so this is cosecant of b is the same thing as 1 over sine of b. So if this is 1 over sine of b, so that really ends up being cosine of b over sine of b. Okay, well, the reason why I focused on these 2 here in the middle out of the 4 parts is because cosine of b minus cosine of b is going to be nothing, and nothing over sine of b, because since they have the same denominators. So basically, these 2 parts cancel each other out. So then you're just left with this minus this. Well, cosecant of b is the same thing as 1 over sine of b. I want to try to make everything over sine of b if possible. So I'm going to bring this term down. So this is cosine of b over, now cotangent of b. Cotangent of b is the same thing as cosine of b over sine of b. So times cosine of b over sine of b. Okay, so now we've got them both over sine of b. So cosine of b times cosine of b is cosine of b squared. So I can then do 1 minus cosine of b squared, cosine squared of b over sine of b. Now, this is going to actually, I can change this now, 1 minus cosine of b. I can change that to sine squared of b using Pythagorean identity. So that this top becomes sine squared of b over sine of b. Now, I think we've seen this before. Sine squared of b is really sine of b times sine of b over sine of b. So these 2 will cancel out, and you're left with sine of b. All of this just to get sine of b. As you can see, that's a pretty complex question. That leaves me with 1 question left, which I want to look at first. Okay, so this question actually took me some time off stream figuring out how to go about doing this question. So I'm actually going to simplify, instead of using FOIL method, I'm actually going to solve this by just simplifying what's inside each of the parentheses and then multiplying the two parentheses by each other. So cosecant of x is the same thing as 1 over sine of x. And cotangent of x, according to the quotient identity, is the same thing as cosine of x over sine of x. So that simplifies down to, since they're both over sine of x, that's 1 minus cosine of x over sine of x. Okay, so this parenthesis is the same thing as this. Now I'm going to try to do the exact same thing on the right-hand side. Secant of x is the same thing as 1 over cosine of x. And then added to 1. Now, this is where you might keep in mind that anything over itself is 1. So I'm going to say cosine of x over cosine of x. Now, I've chosen that because I want the two denominators to be the same. So cosine of x over cosine of x is the same thing as 1. So now this parenthesis is really the same thing as 1 plus cosine of x over cosine of x. Now I can multiply the two by each other. Well, the denominator is easy. That's going to be sine of x times cosine of x. And the numerator is going to, it's differences of squares, which is the nice thing here. It's going to turn into 1 minus cosine squared of x. Now, you can probably figure out where I'm going from here. 1 minus cosine of x is sine of x, or sine squared of x. So sine squared of x over sine of x times cosine of x. So once again, so this is cosine of x times cosine of x is cosine squared of x, and 1 minus cosine squared of x is sine squared of x. So now I can cross this out, and I'm left with sine of x over cosine of x, which now I'm really close because that's really just equal to tangent of x, which should be my answer. All right, thanks again for watching. Yeah, this question right here, as you can see, that's actually took me 5 to 10 minutes off screen just to figure out which was the best way of solving this question, and that's really the toughest part about this. So the more you do this, the more you're going to become familiar with these identities that we're using, and it's really just a puzzle. It's kind of like a Sudoku puzzle. You know, you just have to guess, try some things, see what things kind of work together. Please give it a like if it helped you learn something about simplifying these trig identities, because I know they can be pretty difficult. Hopefully this is going to be a pretty popular video. Thanks again for watching. Have a wonderful day.